If quantum computing was just about breaking cryptographic schemes, then we might as well all pack up and go home. Because governments would care, criminals would care, but 90% of the population won't care. So we might as well give up if that was everything. It's all about the wider use cases and the wider ability to change the world. It's all about being open for how it's going to change as well. So I like to use the analogy of the 1960s in classical computing. There we had it, we sort of knew it had some value. We knew some spaces, but we couldn't have imagined where classical computing has brought us now in the last 40 years. And quantum computing offers the promise of a revolution of the same scale. And it will be about understanding the heuristic uses. Yes, we have some great use cases in cryptography, but it's about how we use it in a much more general and wide ranging possibilities, which will bring the real value here. And so, for example, as you say, taking it and being inventive and creative in how we use it. For example, using the timing here to improve synchronicity across network routing is a big thing. Thinking about the optimization things, how do we think about cases where at the moment we have to do it offline? What would it mean if we could bring it online? If we could change that from an offline optimization to an online optimization to enable us to be more reactive in what we do, for example, in the power grid. So rather than having to treat our wind power as a very constant thing, is what we have to partially do at the moment. If we were doing things online, then we would be much more efficient in how we use our systems and our technologies.